Bonjour. Je suis vraiment désolé, mais je ne parle pas français bien. That's why this talk is going to be given in English. Apologies. I try to master many things. Unfortunately, French is still not one of them. Yes, but I speak Polish. That's my superpower. Yes, welcome to this talk, Java 19 and 20, what's new and noteworthy. The image in the background has something to do with the talk because it's meant to be a deep dive, right? So instead of just surfing or sailing on the surface, we'll try to dive deeper to understand what's happening and what will happen as well in the recent Java versions. Yes, so shortly about me, I've heard some of you folks like discussing how to actually pronounce my name, right? I know the drill. So my name is Piotr PRZYBYL, but you can call me Pierre or Peter or Pedro, whatever you like, as long as you approach another person with the good intentions. I guess it's acceptable. Yeah. So my family name is PRZYBYL, and in like contrary to some Western languages, in Polish, Epsilon or Greek Y is a vowel. So my last name isn't vowel-less, okay? Despite my nickname in Germany, Piotr ohne Vokale. If you'd like to annoy me after this conversation or send me like, I don't know, anything, like DMs, questions, anything, you can do that using my Twitter or my Mastodon profile, right? I've been moved, I guess that's the best description, to a new role, being solution engineer at a company called Atomic Jar, which is a startup. We operate in Europe and North America, and we are the some call us the test containers company, right? So we do test containers and stuff around, and sometimes I also work as a trainer. When I'm not a speaker, I sometimes train people, help them, for example, with Java, and from time to time I try to blog some useful stuff or like poor life advices on my personal page, being softwaregarden.dev. All right, yeah, so this is me on holiday, provided there's a holiday. So you see, even when I'm on holiday, Java is somewhere in the background. I've been programming in Java for, I can say now, majority of its existence, because I've started in Java 1.3, I backported some code to Java 1.2 even, and also like other languages happened to me, like Scala, Go, PHP. I mean, who hasn't been working with PHP back then? Yeah, and the question is, who are you? So who's Java developer? Almost everyone, okay. Any other JVM languages? Scala, Kotlin, Clojure? Okay, so non-JVM languages? Okay, just one person. Okay, very nice, very nice. We still this is also like Java's mindset to get more people. Okay, so now we're going to this more painful part, okay? Who's using Java 20? All right, Java 17. Okay, almost half. Java 11. Okay, poor soul still using Java 8 or below. Oh, I feel sorry for you. I really am, but I hope this talk will give you some arguments to move to newer versions. All right, so this is who you are. A short like description who you can be. We finished our Series A, and so we have like a payroll money and everything secured. So we're looking for new folks who can join us, right? So if you feel fancy, if you think you can join Atomic Jar and help us in one of those roles, you can DM Sydney, or you can DM me, or just approach me after the talk. And also, like disclaimer, what I'm going to use for some of the demos today, it's not mandatory, but it helps. It's Test Containers Cloud. It's a product we're working on. So sometimes it might be easier to use it. And I mean, if I've been working on this as a software engineer, why shouldn't I be using it as a developer, right? So there's a free trial. As far as I can tell, you're not even requested for a credit card number, right? So there is not like, oopsies, I've been testing too long over the last week, so no lunch for next 2 weeks or something. No, it's not going to happen. And little disclaimer before we start, right? Caveat auditoris. So everyone can make a mistake. I am not like any different. I'm not a superhuman or anything. I can make mistakes as well. Hopefully, if I make them here, we'll all like come to like and correct this, right? But please, like especially in these difficult times, try to verify things on your own. Don't trust talking heads from the internet, right? And so on. And there was also one more thing. One more disclaimer, I have the nasty habit of talking too fast, right? And I understand English is not your mother tongue, right? And you're not watching it on YouTube, right? Because we are in this room. Finally, I mean, the conferences are real again. And you can't just play with half the speed. So in case you think I'm talking too fast, right? Just raise your hand and let me know that, hey, slow down because you're talking too fast, okay? I'll try not to do this. All right, so Java 19, let's go to the real part, was released over half a year ago, right? Because now these days Java is released in September and in March. So every 6 months the train leaves, basically. It leaves the station on a regular tick-tock schedule, right? And if a feature or a JAB or enhancement or whatever can make it, it gets into the train. If it can't make it, it waits for another train, basically, right? So we don't have this situation as we were waiting. I don't know if you remember, but for example, we were waiting for Java 9, and then we waited some more, and so on. Now it's not the case, right? If there are enhancements, for example, to garbage collectors or something like this, it doesn't have to be blocked by major features because it has to be Java X, right? It's not the case anymore. So Java 19 got released in September last year. It had, if you take a look at these two Java versions by just number of JABs, they seem to be quite small because only 7 JABs, right? There used to be like 13 or something, so 7 is like half of it. I mean, come on. And these are release notes. There's a link for you if you fancy to read more about this, like in details, if you prefer changelogs. But I hope since you're in this room, you'd like to experience this changelog, right? So this is the right room for this. Java 20 got released half a year later, right? Again, 7 JABs in total, and majority of them is just another round, another preview of certain features, and again, release notes. So these are the JABs from Java 19, right? As you can see, there's this Linux RISC port, and beside that, everything is a preview or incubator, right? So this basically means a new build. New binaries, and here, as you can see, we see everything as an incubator or a preview or anything like this. So it's it's basically like iterating, like getting us closer to certain things. All right, so I think we've covered all the JABs. Thank you very much. Enjoy the conference. No, of course I'm trolling you. Right, so there's this question, right? And you're in this room, and we've done the voting, right, with Java 8, and just one more thing. Anyone using anything below Java 8, like 7 or 6? We're in a good room. Oh, okay. Yeah, nobody. Or maybe if you like, I hope it's true. It's not that you're ashamed of this. I mean, sometimes there might be valid reasons. Okay, so the question is: shall I abandon the latest? Abandon the latest LTS, which at this moment is Java 17, and migrate to Java 20? Right, this is the question you're asking yourself, I guess. And the answer is yes, of course. Yes, that's the answer. Yes, very much. Yeah, I like this answer. Like I brought some jellies from Poland for you, so good one. You're welcome. Right? Yeah, this is the answer. Yeah, this should be our mindset. We shall be using the latest released Java version in like production, in testing and everything. It doesn't mean you have to rewrite all your code because, oh gosh, it's using these idioms or this code from Java 6 and the code is ugly and we have to rewrite it. No. That's not the case, right? Just even you don't have to compile it, right? Just grab the jars and put them in a new JVM, and you can, of course, JDK. Then you can, of course, try to use new features, or if you think like rewriting makes some sense, because, for example, visitor pattern is ugly, and instead you like to have the pattern matching or something. Yeah, I mean, why not, right? But this is it. Like, of course, run it, and. You need to have like really good darn excuse not to use latest Java in production, and I mean really good one, right? because actually there are things we maybe will not be covering them today. But for example, the enhancement to Java garbage collectors, right? And if you're still running Java 11, and chances are, if you're running Java 11 and you're past this painful migration from Java 8 to Java 11, right? Chances are your system will work just fine with Java 20. So just by deploying your jars and using the newest JDK, you might get the performance boost, right? Or, for example, the question is, who has issues with the slow Java startup? Like the system or program starts too slowly. Yeah, keep your hands raised. Okay, who's using Spring? Okay, so it's like more people. All right, but it's like some people make this joke that it's usually a Spring's thing, right? So for example, you can use the CDS archives, right? And their enhancement to various Java versions. And CDS archives basically act like a cache, so the class path doesn't have to be scanned, but instead you just start your machine quickly. Or maybe you'd like to use Graal VM, right? Because it's like going native. But sometimes you can't because of reasons, right? So then archive CDS for the win, right? And yeah, the non-LTS doesn't mean banana soft, right? Or monkey soft, as some people call it. It's just really good, tested, secure software and so on. So it's not like, yeah, we should upgrade only for like LTSs. It's not the case. LTS, more or less, is a business term, right? It's not a technical term. LTS means, and by the way, the different JVM or Java vendors can mark different versions as their long-time supports. I'm not sure if it's the case anymore, but for example, Azure, if I'm not mistaken, used to run like 13 and 15 as if they were supported for longer than 6 months, right? So it's just a business term, meaning you pay some company or someone money, and then when you have an issue, there's someone to reply to your email or pick up the phone. That's the whole thing, right? And it's not that the LTS is like more secure or superior or I don't know what. It's not the case, right? So if you're using OpenJDK build, for example, or like without like support, I mean, what's the deal? Okay, there's been a change to the LTS cadence, meaning now we're going to see LTSs not every 6 releases, but every 4 releases, meaning the next JDK we're going to see in September, JDK 21, is going to be LTS. I mean, from Oracle's point of view, right? Because other companies, as I said, can do that in a different way. So I hope this will urge you to upgrade your systems or dependencies or Docker files even faster. Right. And yes, if something happens, I mean, something terrible, this won't be the case. So in short, what happened to Java over last year? So we had no new language syntax as a standard feature, right? No new keywords, no new contextual keywords or something like this. There are such things, for example, like when with pattern matching, but these are still as preview feature, right? So nothing has changed as a standard feature in the syntax. There's a ton of changes to concurrency. Who has heard about like virtual threads or Project Loom? Yeah, see, like many people. There's a change, or there's going to be a change to how we process the data, especially records, all right? There's going, or it's like ongoing change to native stuff, like how do we manage the off-heap memory, how do we do native calls and whatnot. Yes, so the preview features. Have you ever used preview feature? Oh, just one hand, okay. Okay, 2 hands, very nice. We won't go into details, but what I'm going to show you today, and also if you're watching this recording, this might be important, and many of them are preview features, meaning you have to opt in explicitly, right? It's implementation of JAP 12, and it actually boils down to using this switch -- enable -- preview for when you compile, when you run your stuff in Gradle and Maven and so on, right? So to set it in Gradle, you set it basically like this, right? In Maven, you set it more or less like this. It's important for the compiler arguments and also like for the configuration. So it's like when you run this stuff or you test, and the same applies when we have to add the modules. We have to go for -- add modules, right? And in IntelliJ, if you were not using any build tool, or sometimes there might be like some glitches or something. It didn't update it for 20, but it works for 20 as well. You have to sometimes make sure that the versions for the sources and for the modules are set, for example, as 20 preview, right? Because there might be some issues. So yeah, I mean, the indexing might be taking too long or something. Oh, I shouldn't have said that. Okay. It seems I might have been issues. Do I have internet or not? Let me check. I should have internet. Why isn't it there? Yes. Okay. So a shameless plug. If you're interested more, like how it really works under the hood and how the compatibility between versions, sorry, like for given version is ensured and so on. I've been discussing this more in Belgium. So please go and watch this video, right? If you're interested. Okay. So now we're going to jump to the concurrency thing, right? And there's a number of issues with concurrency as we see it in Java or use in modern versions of Java. So there was this time back then when we had to do something in parallel or concurrently. And let's not go deeply into this, like should we use this term or that term? When we had to do two things or more things at the same time, back in the day, we used processes, right? We were forking processes, sub-processes, zombies, parents, you know the drill. And then there was this issue that apparently starting a new process was too costly and too slow from our perspective, like when we had to run the system. So then we went for threads, right? And then threads were okay until they weren't. Basically, because we reached the same stage that they were too slow and too costly to start, right? So then, for example, in our JVM world or Java world, then there was this reactive paradigm, right? Applied or used and so on. And yeah, the number is limited because the good old threads, as we know them in Java, are backed by a platform or operating system threads. So we can have as many threads as the operating system can give us, right? This is like OS dependent or platform dependent, and therefore we have like limited number of them, which means, for example, if we have like huge usage peaks. We can't, for example, follow this thread per request approach because we might have easily more requests, especially on, like, I don't know, like Black Friday or something like this, more requests than we have threads available, right? No, and it's like no-brainer to have this. And then, okay, we invented the reactive thing. Who has tried to debug the reactive stack without IntelliJ? Exactly. It's not easy, right? I mean, they did this magic. They glue the stack traces and whatnot to allow us like seeing like, and you can then just track back where is it coming from, right? But then it's not easy, right? To debug and troubleshoot reactive stuff. It's doing this job, but it's more complicated. I mean, we have more performance, but it came at a cost of readability. And we don't have like async or await, for example, like in JavaScript world, right? Then they go for async call and then can await and so on and so on. So we don't have anything like this in Java. I mean, as a standard feature yet. Even in Java 20, we have these preview features or concurrent module. All right. So the virtual threads from Project Loom, if you haven't heard of it, raises this question in many heads. Many heads like try to answer it. Is this the biggest change since Lambda, right? And they keep thinking. And basically, there are two camps. In Java communities, I observe two camps. And some people are saying, yes, this is the biggest change in Java since introduction of Lambda in Java 8. And some other people saying, no, this is not true. This is even bigger. Right? So this is what we might observe in coming months and years in Java, that maybe this will be or improve our predictability and our like the systems we create more than introduction of Lambda and therefore streams and everything. Because Lambdas, along with, for example, functional interface and so on, enabled us the streams and many other things, right? So they are the cornerstone. Lambdas, right? And so are the virtual threads. They might be the cornerstone of many improvements to concurrency, new idioms, and so on. We're going to see this just in a few minutes, I hope. So Yes, virtual threads, they are a second preview of Java 20, but let's not fool ourselves, they were prepared for years, right? There were different names used for them, like fibers or whatnot. So if you were like tracing this thing, yeah, so now it's like a second preview feature in Java 20. This is the whole JEP. You can click on this link, you can read the whole description if you fancy. By the way, the slides are online as well. You should be seeing the URL down here, right? So you can just grab the slides and you're good to go. So virtual threads, let's do some voting maybe, okay? Let's do some live poll. Virtual threads are great for, or can be great for, debugging, switching between threads, waiting, and reducing memory consumption. So who says debugging? They're the best for debugging. Okay, you don't know. For switching? For waiting, reducing memory consumption, I would say it's all of them. That's the nice part, right? That they might be great for everything, all of these aspects, right? So the whole idea, I mean, this is not like official OpenJDK talk. These are my thoughts, right? And the way I find this is this: it's really nice because they don't reinvent the wheel. Right, we don't have any other new type, like for example, like this fiber or whatnot. So we are basically keeping or sticking to the good old thread model we know since Java, like the beginnings of Java, like Java 1.2 or whatever that was, right? And under the hood, they're carried by the platform or operating system thread. So there's like nothing new in this area. So I mean, Paris, right? Like a huge city, traffic jams. I guess you know them all too well and whatnot. And one of the ideas, right, is like this: let's not have, for example, so we don't have like a car, 2 cars, or 3 cars. Let's just rely, for example, on taxis or Uber or whatever, right? And then because what's the problem? Okay, you leave your apartment, right? You decided let's go have a nice dinner with your friends, and so everyone comes to the restaurant. In their car, right? And they need to block, for example, they going through the traffic, and then they have to park the car at the restaurant, and the car is staying there. It's idle. It's blocking the like everything, the resources, the street, like parking lot, and everything, right? And the idea might be this: instead of like going there in our own car that will block it, we can just car share, whether it's taxi or Uber or Bolt or whatever, right? And we go to that destination, right? And then the car, the actual resource, can serve other people, right? So other people can call the cab, the taxi driver will get them and whatnot. And when we need to get back home, we can just call the taxi, right? And they will come and get us home. I mean, provided there's enough taxis and whatnot, right? And this is more or less the idea of virtual threads, the way I see it. So instead of each task being given its own resource created and managed by the operating system or one-to-one by operating system, right? There's just this taxi corporation called fork and join pool, right? And whenever there's a need expressed by any task wrapped in a virtual thread to do some computation, right? If there are like resources in this fork join pool, this thread is, for example, going to be driven from point A to point B. So that's the whole idea, right, under the hood. They are supposed to be cheaper to start. I mean, not supposed. They are cheaper to start. They are faster to start. They take less memory. Instead of like kilobytes, they just take bytes, more or less like, I don't know, 300 bytes or something for the stack. And the stack is not living like for the regular stacks, right, in somewhere else, but it's living in a heap. Right, so it can grow. For example, just like our collections can grow, you can add more items to set or list, right? And when they're waiting, and this is like the good benefit from using virtual thread, when they're waiting for something, especially for I/O. So we made this blocking call for a database, for a network, for file system. Instead of keeping the engine running, imagine you're dining with your friends in a restaurant, and you parked your car and the engine is running, right? and so it's using the fuel and everything. So the whole idea here is like when such a thing happens, the thread, the underlying carrier thread is not blocked, right? Unless it is, and that's a misfortune. We'll try to avoid this. And they're always daemons with normal priority. Therefore, because they are so cheap and easy to start, they allow us back or go back to this thread per request model, which is easy to comprehend, debug, and whatnot, right? And therefore, they improve scalability for asynchronous style. Okay, and the whole idea for this talk is that I will try to like prove what I'm saying by running a series of demos, right? So let's do some demos, and yeah, testing company and whatnot. I should be having, let's go for this concurrency thing, virtual threads, where is it? Now I have, no, it's not this thing, virtual threads, it should be somewhere in here. Virtual threads, no, it's not this. Sorry, it's because it's SRC main, so in tests, yeah, this thing. So let me run this. Let's hope that all the tests are green. Yes, they are, very nice. As you can see, I'm using the incubator module, right? Yes, and there's a series of tests, right? So what they can tell us, whenever I'm trying to stop, suspend, or resume virtual thread, I'm going to be thrown unsupported operation exception. And if I'm trying to set it to be like non-daemon thread, right? A daemon thread in JDK means that when the program runs, there has to be at least one non-daemon thread, right? If all the threads are daemons, the process stops, right? So therefore, a virtual thread won't prevent your application from stopping. Okay, but we can set it to be daemon, but it's like no op, it doesn't do anything, right? It's just like, okay. We can try to set different priority, but guess what? It will be normal anyway, right, when we try to get it. And there are also like changes or like things that were or still are in Java 19 or 20, but as far as I can tell, they're going to be gone in Java 21, right? So basically, we could disable or opt out from thread locals on inheritable thread locals for virtual threads. As far as I know, in Java 21, this won't be the case, so they won't differ in this regard from regular threads, right? So this is like the basics, like how do they feel these virtual threads? Okay, so you might be wondering, okay, which system flag shall I use? Like a -d or something like properties file or environment variable, so my program starts using virtual threads. Okay, there's no such thing. Basically, you have to you need to change your source code. You need to tell inside your program, here I want to have virtual thread, right? Started for my task, and this can happen in a number of ways. What you could see just in the previous thing, right? We can provide this runnable here, runnable, and then we can say of virtual thread, and then there is start, right? And of course, there's like an equivalent method called of platform. So we can also create platform threads since Java 19 like this. And if you think you can exchange one dot for one extra character, there's also a way for this. So we can just start this virtual thread immediately by providing it runnable. And if you fancy to have executors, because you need executor, because your code is built around executors, very good. Then you go for new virtual thread per task executor. And if you need to inject some thread factory, right, you can go thread of virtual factory. It will create you virtual threads, right? So these are examples how you can switch inside your code into virtual threads, right? I guess this might be the most important thing in this very talk. So that virtual threads won't magically squeeze the lemon, the silicon lemon that you have called CPU and get you more juice. It won't happen automatically. It might happen in certain cases, but it's not always given, right? It depends on what your system is actually doing, how it's behaving, on its domain, in context, and everything, right? So just as like a seasoned IT consultant, we could always say it depends, right? So because there are these things. For example, virtual threads are they are not GC roots, right? So garbage collector won't start from them. So in this regard, it won't slow your system. But because their stack traces are dynamic, right, and they are kept on the heap, it means there will be more work for the garbage collector, right? So if you don't benefit in any other aspect from having virtual threads, maybe you don't want to start them because they will pollute your heap, right? And they don't guarantee first CPU usage. What does it mean? It might be good, it might be bad, depends what you need. If you need latency, this might be bad. If you need throughput because, like for example, batch processing, this might be good. What does it mean? If you have like given number of threads running, right, and you have more tasks than you have actual or like CPU cores, right? So for the regular threads, it works more or less like this, that after running for some time, the operating system will decide, okay, now it's time for this other thread to have some CPU time, right? And this is how regular threads are working here. And virtual threads are greedy in this respect, in this aspect. So as long as they have something to do and they are not blocking for I/O, for network, for file system, for something like this, they will keep on running, right? Which means there will be less context switches. Which might be good if you're after throughput, and not so good if you want to like distribute your CPU power equally among all of your tasks, right? So that's this. And yeah, there's this also, as I said, the pool of the actual threads, of the carrier threads, is called fork join pool. And currently there is no other, like there's no way to provide your own pool of the carrier threads. Okay, so of course we can change the size of this fork join pool and whatnot, but we can't say, hey, like for virtual threads, use these other threads, like native threads, so to say. It's not possible, and therefore, because of the nature of fork join pool, I mean, it's work stealing, right? So if one carrier thread decides, okay, I have nothing to do, it may steal the work from this other virtual thread. Which means, for example, that they might be running, or this other virtual thread could have been running on a different CPU core, which means that there will be cache misses because virtual threads don't live in kernel space, they live in a user space, right? Which means that the thing might be loaded from like a higher level of a cache or something like this, right? So this is like, that's why I can't tell you just go for virtual threads and you'll always be faster, right? It's nuanced thing. I mean, I guess it won't harm you easily, but sometimes you could see like a performance degradation. Okay, and so let's try to run some experiments because we have more time for demos today. Right, so let's try this thing. I have such executors demo. So what I will be trying to do is to start 30,000 tasks. Right, just tasks, and the task is going to be quite dumb, so don't do that at home, don't do that at production, okay? It's going to sleep, basically. And as you can see, now we can sleep. This is also like one of the changes. Now thread sleep accepts not only milliseconds, but can also accept a duration, right? So if you don't have to like calculate how many seconds, you just create duration and you're good to go, right? So these tasks are really dummy. They're not going to do anything fancy. They're just going to sleep. And every 5,000. Oh, sorry, is wrong. Yeah, this example. Every 5,000 tasks, we're going to see what's the current count, right? And yeah, we're going to like simulate that we're doing something for 5 seconds, right? And we'll try to see how this works. Okay, who thinks this code will work? Who says I can handle on my machine 30,000 threads? You think it will work? Okay. So I guess the other ones like say it won't work, or you don't mind, right? Let's see. Let's experiment. We have some time to experiment. Come come on. Yeah, okay, so it's starting the threads. Okay, 15,000, 20, 25,000, 30,000. Yeah, okay, so it worked. And we were like, okay, 11 seconds, right? Okay, so let's try. Let's see it, like the demo goats are with us today. Let's hope that's the case. Let's see if it works for 35,000. Okay, then 20, 30, 30, come on, 35, okay. Let's see, it worked. I mean, it depends on the like power profile and whatnot. Let's see, yes, if it works for 50,000. Oh no, it doesn't work for 50,000. So how many did we have? Let me see. Oh, come on, this scrolling. Oh gosh. Let's scroll up, let's scroll up. You see the threads had an error, right? So, oh, this time it failed even sooner, right? Because it tried to create these threads and so on. Because, yeah, it creates the threads like, you know, concurrent stuff and so on. So what has happened? Right, failed to protect bytes for memory and whatnot. So we basically have not enough memory, right? This is what happened. Yeah, and for subsequent threads, it failed as well. Right, and now we can try to switch to virtual threads. So instead of new cached thread pool, we're going to use new virtual thread per task executor. Right? And let's see how it works. Okay, it created 50,000 threads. Very nice. So let's try to go for 500,000 threads. Okay, will it work? Will it work? Won't it work? What do you think? It still works, as you can see. Yeah, we are it's this demo is cheating a bit because we're not waiting for these threads to finish, right? We're not joining. That's why it's finishing so early. Okay, I'm not sure I've ever tried this. Shall we try 1 million? Let's see. I guess the busiest part of this demo is the system printing out how many threads it was able to create or spawn. Right? Okay, 800, 900 million. Right? And let's stop here. Let's not go any further. I guess having million requests in like 5 seconds, in 5 seconds span is like, I guess when our systems reach this problem, we'll be rich enough to like outsource it to somebody else. Okay, so let's not go deeper. Right? It will be somebody else's problem then, not ours. Right? Yes. Okay. So as you can see, this is the property, right? And it happens because these. Okay, I could create probably 50,000 threads on my machine, right? Because it's like I don't know, 12 or 16 cores, something like this, and I could tune the stack size and whatnot, so I could fit it. But then there will be and like I could change like power settings, right? But then there will be like this limit. So when we want to organize our work around threads, because threads is like what we know, what we like, or for example, what we're familiar with, and most importantly, that there are these libraries which are already using thread model, I mean thread API or something, then they won't recognize that they're using or utilizing virtual thread instead of like regular thread, right? So it will be easier in this regard. And there are, for example, guys from Helidon are doing amazing things. So instead of Jetty, I don't know how is it called, Nima or something like this, I forgot, sorry. But basically, they already creating web server written in Java using virtual threads, right? And in certain scenarios, it's faster than Jetty. I would say it's quite impressive, right? But yeah. Maybe you don't have a need for anything like this. Right. See, so there are caveats to using virtual threads as well. It's not always like go for them. There are things we shouldn't be doing with virtual threads, right? There are such things, and for example, we shall not reuse them. So one of the ideas for, I mean, regular threads or old threads or native threads or platform threads, whatever we call them, are costly to create because time and CPU resources, right? And memory. So we used to reuse them. That was one reason. Another reason to reuse them was, We didn't want to have like, we wanted to handle back pressures in like this primitive way, or maybe not primitive, let's say in this way, basically, right? So let's say I have no more than 20,000 threads, so I won't handle more than 20,000 requests concurrently, right? The others will be, I don't know, queued, rejected, whatever. And this is not what we should be doing with virtual threads. They are so cheap and fast to start that we should basically not reuse them. And if you need a rate limiting mechanism, you should be using something else. I don't know, semaphores, countdown latches, whatever, right? Whatever that there is, like what of these concurrency mechanisms. Yeah, and pooling I already covered. And we also shouldn't pin them. What's pin them? Let's go back to this example with taxis, right? So you got to the restaurant in a taxi, and I don't know, maybe you know it from these gangster films, that they leave this one guy in the car and say, keep the engine running, right? Because they're robbing the bag and they need to get quickly back, right? So imagine you go to the restaurant, and instead of letting the taxi driver to drive other people in the city, you just say, stay here and keep the engine running. Which means you're basically downgrading or neglecting all the benefits of virtual threads, right? That's the thing. And it can happen in two cases when you pin your virtual thread. First, when we call the native stuff, right? When we call native method or something, and I guess it kind of makes sense, because if you're calling native stuff, then it's easy to mess up with memory, with like layouts and whatnot. So maybe let's not do this, right? So that's one thing. And the other thing, but okay, who's calling native stuff on daily basis? Like, from your own code, do you call native stuff? Exactly, right? I mean, the libraries or frameworks might do that, but nobody raised their hand. The other thing is calling these blocking I/O inside synchronized block or method, right? And then in current implementation, as far as I can tell, it's pinning our virtual thread to the carrier thread, meaning the engine is still running, right? And this is, I would say, it's a bad thing, because the whole purpose of going for virtual threads is that you want to like use these carrier threads for other virtual threads, right? So there are two ways how to detect this if it's happening. So first you can go for these JDK trace pin threads, and you can go for short or full. Full has nice benefit because it will print you the whole stack trace. Like it will tell you, like finger point, look, in this line of code, you're pinning your virtual thread, right? This is not what you're gonna do, what you wanna do. That's one thing. And the other thing is using Java Flight Recorder events. Who's using Java Flight Recorder? People, you should really use Java Flight Recorder. It's an awesome tool, really. I mean, to learn about your system, your assumptions, like whatever. I mean, for performance, it should be the first tool, I guess, of your choice. Anyway, now if your virtual thread is pinned, right? Pins the carrier thread. It will also emit after 20 milliseconds, I guess, Java Flight Recorder event like virtual thread pinned or something like this, right? And so the question is, how do you detect this, right? How do you detect this? Because let's say you visited your code, you went into your code, you replaced the locations where you use, for example, executor service with this new virtual thread executor service, right? And now you want to make sure that your system is not pinning virtual threads, right? So you're not like misusing it, and like going through all these lines of concurrent code might be a really challenging thing, right? So there is this simple system I'd like to test today, right? So we have this Gritter microservice, right? And inside it's using this HTTP client that became part of Java 11, if I'm not mistaken, right? So we're going to make HTTP calls, right? Network calls. And it's going to call basically download index.html file, which is going to be hosted using Nginx, right? And so this is normally the call, and we could test if it's not pinning or something. But then, if this response from this server is really fast, I won't be able to test it, right? Because no thread will be pinned. So for this testing scenarios, because let's say if I have this Gritter microservice and Nginx deployed on my machine, I mean calling like local network will be blazing fast, right? So what I'm going to introduce here is toxic proxy. if you need to do any chaos engineering, Proxy is really amazing thing because it can simulate like latencies, jitter, network issues, and whatnot. So how do you basically use or create network issues inside your tests, right? You go for Proxy, and you can't go wrong with it, I guess. And then I don't have to deploy them or install them or anything like this. Actually, I might use an assistant for this demo. Is there anyone who'd like to join me on the stage? Just sit here for 2 minutes. Any volunteers? Come on, guys, I don't bite. Okay. Let's put hands together for this brave gentleman. Okay, if you just mind to sit, I won't do any harm for you, I promise, right? And for these things, we're going to use test containers, right? The libraries, so we're going to run all of these in test containers, right? Okay, so how do we do these? I should have a test for this. I mean, you can stand if you'd like to watch the code with me. I don't mind. I don't know if you see it from there. Right, I should be having this test here, right? And yeah, let's enable it. I mean, I see some like nasty people got to this test and disable it. Okay, so what do we do? I have this index.html file, right, in here. And what I'm going to do is, I'm going to create Nginx container, right, of this version from like Docker Hub, right? And then I'm going to copy this index file to here. It's the default location for Nginx, and I'll be waiting for this Nginx container to start up, right? And then I'm going to create Proxy container, right? This thing, right, here, and then I'm starting them. And then I'm going to say, hey, Proxy, I want to introduce latency of 500 milliseconds plus minus 20 milliseconds, right? So this is basically this thing. And then I'm going to, I created my, like this thing, right? You know, the Maven style, right? So this is like my program. I run it here using Maven package or something. I build it. And then I'm going to use Java's JDK. OpenJDK, and I'm going to copy this jar file to this location, and I'm going to run it. And basically, this is just to make sure that it doesn't exit prematurely. Then I start it, and then this is the format I'm going to call. So over this Proxy, right, I'm going to make this calls, and I'm telling my HTTP client in here. Run your stuff and enable preview because this is still not Java 21, and trace the spin threads to 4, meaning if there is like any thread is pinned, let me know, right? And then if the output contains on pinned, it shouldn't work, right? So let me start this thing. And do you think the test will pass or not? Okay, it was pulling the images, right? So the Nginx, Proxy, and whatnot. And now it's pulling the images of OpenJDK. Okay, starting the JDK. The test has passed, meaning we didn't detect a single thread being pinned. Sorry, and it's because I already reviewed this code. And let me then go to this thingy. It's a greeting obtainer, and see, let's say I have this method as synchronized, and it's getting this greeting in a synchronized way. And this is when I'm using this client to send this request, right? So I'm trying to make this a network call, right, inside a synchronized method or block. And as we know from our test setup, because the test setup is here, it's going to take at least 450 milliseconds, right? So therefore, at least one thing should be, one virtual thread should be blocked. So let's then run Maven. Let's go, like, for example, the CI way, clean package. And let's see if the tests are running. Some tests are running. Oh, and the test didn't pass. Why the test didn't pass? It didn't pass because, see, this test didn't pass because expected 0 but was 1. Okay, there's one thing, and it's here. Okay, yeah, it's this thing here. See, so this is the test because there should be no pinned events, and apparently there are some pinned events, right? Because this is the output of the container, and we shall see somewhere there on pinned, or maybe we can do it like this. Let me debug it here. Let's debug this test with these containers. Right, and so this is the result, and in the result you see this is the standard error, right? Okay, oh, invalid file because, okay, all right, so let me, let's build it then without, see the demo gods maybe aren't with me today, with, how is it called? Not package, but, okay, let's say with package, but, sorry, package, but what was the command? Skip test or something, right? You don't do that at home, remember. True, right? Basically, what I'm trying now to build this jar file with this incorrect version. That's why it doesn't work, because the test isn't, you know, isn't letting it build, right? Okay, this is it. And now I'm going to run this thing again. Okay. Okay, all right, and now we see, yes, standard output is this. Okay, how do I should click here? See, and this is it. Because I said show the spin threads, I got this thing, and it tells me that something got pinned, right? And it got pinned in here exactly. You see in this get greeting lambda in virtual threads 49. So this is where I got my thread pinned. Right? Yeah, so this is a way for us, for example, to test our system. You see, I created the whole system. I created like a network environment for it, and I basically copied this jar file to the container and started everything. And now I have a question to you, right? Did you hear fans roaring? Was this my computer? Was it quiet or was it loud?
Loud.
It was loud. Did you hear fans or something? No, exactly. Sorry, that was what I wanted you to hear. That's one for you. Thank you very much. Thank you. Thank you. Exactly. I wanted you to listen. My machine wasn't roaring, and why wasn't it roaring? You could say the dude started 3 containers, right? And it didn't consume his CPU and something like this. It's exactly why I'm using for this demos test containers cloud, so the thing we were building, right? So basically, it's running all the containers in the cloud, right? So the test is running on my machine, and that's why it's not using my CPU, my memory, right? And the containers are offloaded there. And if you'd like to understand this demo deeper, or other demos, or you master test containers knowledge, I'm running a workshop tomorrow, 10:45, I believe, right? So we can come and we'll have again 3 hours just for test containers, right? To understand how it works. Right. So this is like that. That's why I love integration tests, for example. So you can change one thing, and then how do you? I mean, is it really that easy to mock blocking network call? I'm not so sure about this. I mean, there are ways of doing this, but it's not easy, right? So let me just go back to this synchronized here. So the test shall pass then. Yes, that's why I like working for my company and everything. Yeah, now they are passing. So no, because it's still skipping tests. No, don't do that at home. It was demo only. Yeah, because we introduced chicken and egg problem, right? The jar wasn't built. Oh, it's still like this other thing. We'll get to that. We'll get to that while it's not working. Come on. Okay. Yeah, the whole. If you prefer not to watch this, but if you prefer to run it on your own, I've described this whole process on my blog post. Right, you can click on this link, and there's like whole entry describing the steps and whatnot, how to get there, how to build such a like basically how to build your infrastructure, testing infrastructure as a code. Right. Okay, let's go to testing concurrency. Okay, so it's second. I mean. Do you have any questions related to virtual threads or Project Loom so far? Right? Okay, there's one question. Come on. Yes? Uh-huh. Uh, y- yes and no. I mean, let me. The question is if I'm getting it correctly, if Project Loom is about these virtual threads. So it's yes, but not only. Basically, there's when they develop OpenJDK, right? There's a concept of these umbrella projects, right? So Project Loom is responsible, or like jabs or enhancements or changes to the concurrency stuff, like threads, structured concurrency that we're going to discuss right now, and so on, are grouped under the umbrella of Project Loom, right? Okay, then there are, for example, there is a project Valhalla, which is meant, there was this talk, I guess, earlier today, right? Describing like value objects so that there will be objects without header and whatnot. There is project Amber, for example, which gave us records, and then we'll go through to pattern matching later on and so on. There's project Panama, responsible for the native stuff, right? So there are these, instead of like these single jabs, like pieces of documentation, they are also like grouped together in these umbrella projects. Does it answer your question? Okay, thank you. Yeah, so structured concurrency. Yeah. Which API did I use to create the containers? Who can create containers using Docker? Let me ask it like this, okay? Do you folks know? Okay, yeah. So you go to your terminal, then you can like pull the image and you run the containers and write this, right? There is a whole set of libraries called test containers. Maybe this is like an umbrella name again. Let me show you that quickly. Right, and you basically import them, see? And so there's like the most popular library is Java, but Go and .NET are really catching up, I need to say. And this is it. So I can basically create containers in Java code, right? So as you can see, this is just Java code. I just need to have working Docker compatible environment. Should that be our cloud, or you have like local Docker, like for Linux or Docker desktop or whatnot, just something that's capable of running containers, right? And then as you can see, I'm creating the container, and then I'm like starting the containers right here or here in parallel. So this is it, right? The whole setup for the infrastructure needed for these tests is done in Java, or can be equally done in .NET, in Go, and Node.js, or whatever you need, right? Right. So this, I mean, the two most popular modules we have in test containers are for PostgreSQL and for Kafka. All right. So if you need like PostgreSQL or Kafka in your test, this is how you can create them. Does it answer your question? Okay. Thank you. Another one. If the question is there a way to see virtual threads in like Visual VM or something like this? It's a good question. I would say like this. I don't think I can provide you the full answer because I'm not Visual VM expert, right? But by just the way how they work, you shall. I mean, until these tools are aware of virtual threads, to a certain degree, and if it's possible, right, in the first place, we shall see them basically as code executed based on this fork join pool, right? So if you have like a tons of stuff running, and I guess your question is going somewhere into this profiling or performance issues, right? For example, because why would you use such tool? Then you would see like excessive usage of fork join pool, right? In using these tools right now, the way I imagine it would work, right? Any more questions? Okay, let's go then for structured concurrency. Yeah, structured concurrency. So it's the way I see it, it's about providing better idioms for multi-threaded code, right? Instead of like creating these threads just basically by calling new thread or thread of virtual or something, we can just go for structured concurrency. And it should also, not only should it give us better idioms, but also help eliminating thread leaks and cancellation delays. We'll get to that. And it's without touching current concurrent stuff, meaning it won't deprecate any API, it won't remove any API, it will just give us more things to do stuff concurrently, right? Or organize concurrent issues. Yeah, and for now, it's not replacing interruption with cancellation. So interruption and interrupted exception and so on are still staying with us, right? At least for now. And this is how the code might look like, right? So, well, actually, I should maybe show you that in IntelliJ, because why not? Where is it? Structured concurrency. Yes, okay. This demo. So, we'll use a simple story for this demo. Let's say you have to create a system for this scoreboard, right? So, for example, there's like a game or competition, I don't know, and we have to display like a person or person's name and the current score, like the number of points they have, right? And the thing is like this: we have two microservices, right? Because we are microservice frenzy these days, and one microservice is able to tell you like person's name and person's ID, and the other system can tell you person's ID and current score, right? So we have to call this system and that system, and based on their IDs, we have to merge the results to present just the name and score, right? So this is what we're going to do. Okay, therefore we have name service and score service, right? And okay, and we're going to start with this sequential scoreboard, right? Let's see if this code runs. Please do run. Okay. Okay, so it turns out this code worked for 2 seconds more or less, and we have 3 people, Krzysztof scoring 300 points, Susan with 100 points, and Joe also having 100 points, okay? So we have this sequential, I guess this is like gives you some hint, right? And you see something like this, right? And you know it takes 2 seconds, and then your boss comes and says, listen, dude, we have to make this faster. So what do you do then? Yeah, who said that? Yeah, I have jealous for you. Will you catch them? Because that's you're a perfect employee. I mean, great developer. Try to catch. I throw, you catch. Oh, sorry. Almost. Sorry. Yeah, I'm not good at throwing. I throw exceptions better than jellies. Sorry. Yes. Yeah. This is it. Exactly. We try to do this concurrently. So instead of going for a sequential thing, because this thing takes let's say a second. This thing takes a second. So second after second, we have 2 seconds, right? Very nice. So let's try to go for this. Use these completable futures and whatnot. And so we can see we create these executors and. Voila, we're going to create this new virtual threads, right? So we instantly better to this yearly review. Okay. And then we submit one thing, we submit the other thing. They're working they're working concurrently, right? And now, what would you say? How long this should take? Sorry. Twice less, so? Half, okay, yeah, half. So around a second. Very nice. I mean, too many correct answers. Sorry, I can't give jellies for such occasion. I have just like a few left. Okay, but let's see. Yeah, you were right. Bravo, you were right. It's more or less like 1 second, yeah? Okay, but then let me be a little bit nasty. Let's say that this thing fails, okay? I'm simulating failure now. To make it easier now, I'm not going with like a toxic proxy and full scale. This is like just demo, okay? So the named things, getting names, fails instantly, right? It doesn't even sleep for this 1 second. It will fail. So now the question is the same. How long will it take? Yes. How long will this execution take if this thing breaks instantly? 1 second. 1 second. Any other options? 0 seconds. Someone says, you're saying it will break instantly. 2 seconds, anyone? Okay, no 2 seconds. So we have 0 seconds and 1 second, right? Yes, it took 1 second. I guess you were the first to answer 1 second, okay? Grab some. All right. Yes, 1 second. Why did it take 1 second, no 0 second, as some of us have guessed? It's because this thing, when it fails, it doesn't inform this thing, hey, I failed, there's no point in waiting for me, okay? Because this is it. We need every result from every call to create this combined, this merge answer, right? And therefore, we don't have this cancellation. So we could like subscribe these features so they would be observing each other. And with 2 features, that's quite, achievable. Now imagine we have 4 calls. And then each of these features have to observe the other 3. And do you know this callback hell story like from JavaScript or like from React? Yeah, that's the thing. Exactly. So maybe it's not the simplest idiom to create, like the simplest idiom to write. And therefore, we might go for this structured scoreboard using the new thing that we're going to have one day in Java. And it works like this. You see, it's quite similar. Instead of executor, we create a structured task scope, right? And we say shut down on failure, because if there's any failure, we just want to tell everybody, okay, there's no reason to wake, right? There's nothing to see here, please disperse, right? This is what we're gonna do. And you see, the calls look pretty similar, in just now I'm not submitting, but forking them. Yeah, okay. And then I have to do this join and throw it failed, and then I'm also like getting the results and combining them. And now, how long will it take? 0 seconds, or close to 0 seconds. 1 second. Nobody from, yes, I spoiled it. It was really dad joke, okay. I spoiled it. Yeah, because I told you what it will do. Okay, no class defined. Oh gosh, no, please, not again. Oh, not again. Now it's, maybe it was that thing we should have. Where's this VM arguments, Alt V, and it should go for, what's the name of the module? Yes, this thing. See? Okay, let's try, because it's still not production ready, right? Let's try and go here for the VM options, add modules, fingers crossed. Let's try. Will it work now? Yes, it worked. Very nice. And now, as you can see, it failed instantly, right? So basically, we got we got the cancellation for free. We don't have to subscribe these features so they're calling each other in every possible configuration, right? So we end up with the, I don't know, N pentagon, whatever. Or like this star structure, right? Instead, we get this cancellation for free. So if we say shut down on failure, then if one of them fails, everybody else is instantly notified, stop working, cancel what you working on. I'm sorry, I don't understand the question. Yeah. Yeah, I think it would be okay. That's a good question, but it's I guess it was for the loop. That's a good question. I was using the sleep here. I don't know. I mean, the code is here. You have the perfect homework. Please share the results. Very nice. Yeah, honestly, I didn't check it with the like super busy thing because I guess it was like the primary thing. It was designed to be calling like external systems, but yeah, maybe for a loop. Yeah, so this is it, and now let's try to misuse the thingy. So now it shouldn't, and now I have to be like mindful where I click, because when I click here, it might not work, but when I click here, it should work because of this add modules thingy. Oh gosh, it's still the same. See, now it's okay. Let's try click here. Oh, now I'm saying this, and it still doesn't have this. Okay, oh yes, no, okay. Of course, now it's expected exception, right. It's now I'm misusing this concurrency, and we shouldn't be doing these things. Yes, so where's this misuse? That was expected, sorry. This misuse is here, right? See, so when I have this scope and I want to fork on this scope, like to submit another task, right? It will work here, and if I like pass this scope inside and I fork inside the I go deeper inside this tree, forking will work. I mean, so the child, or let's put it this way, a child of this fork can fork deeper and deeper and deeper, right? That's okay. But if I have another thread, right, and this thread doesn't own or isn't with this structured task scope, it cannot fork on this scope, right? And this is what it tells me. Current thread not owner of the or thread in flock, right? So it's not owner of this, or it's not in the flock, like deeper inside of this. That's why this doesn't work, right? Bad code removed. Oh, let me just comment. Maybe we'll use it later. I know. Yeah. And then if I do another mistake with the scope concurrency, yes. Okay, that's using this. Okay, I'm not showing it because I have to call this join, right? If I don't use the join, okay, now it's failed because this oopsies. Okay, now I have to comment this, right? Task has not completed. It has thrown an exception, and maybe I just did a bad job with this demo because it wrote me this message. It wrote or threw an exception. Task has not completed, right? And it threw this exception because I forgot to join or join until, right? So this is how this idiom works, or is supposed to work in Java. We create a scope. We create as many, we fork as many tasks as we want, right? And then we have to join and wait for them to complete, right? Just as we join for a thread, right? If we don't join, we'll get an exception thrown. And now when I try to rerun it, it's working, right? So yes, don't forget to join or join until. And there is also there are two default scopes. The other one is this, shutdown or success. And I imagine potential usage for this would be like this. You have two caches and a database, right? And then it might be that you have the username cached, for example, because usernames aren't the thing that change that frequently. Score can change, right? So it's tricky to cache, but the username is not. And then you might be asking one cache, another cache, and a database, and whoever provides you the answer as the first one, it's okay, right? And therefore you cancel or notify all other forked tasks. There is no reason for you to work. I already have the name, right? So then you go for the shutdown on success. And if you need everything, you need shutdown on failure. And if you need something fancier, then you can implement your own task scope. It's like, I mean, the API is extensible or implementable, to put it that way. Do you have any questions to scope concurrency? No other questions, okay. So let's go to scope values, which is also incubator module in Java 20. Yeah, this thingy. So in a way, there are one-way immutable thread locals, right? With bounded lifetime, and this lifetime can be visible in code or traced in code easier than thread local. Let me ask you this question. Have you ever had this need to debug code and trace thread locals? Yeah, it happens sometimes, right? It's not that common, but when it happens, it's really painful because it may turn out that for example, the thread was pulled and it was handling like the previous request, and therefore, the thread was like in operation yesterday, right? And just the code that put that thread local didn't clean after, right? And now today we see Joe logged as Susan because user ID was like kept there in this thread local or something like this, right? And what should this give us in return is simplified reasoning about the code and improved performance. And performance mainly because this one-way thingy is immutable, right? And if you have immutable thing, we don't have to clone it for every thread, right? So if you have immutable scope value, every thread that we create doesn't have to, or this task in structured concurrency doesn't have to get its own copy because the copy is mutable, right? And this is how we can defensively ensure that, for example, when we have this getter, right? And when somebody calls a get on your collection, in Java, you have to wrap it into this unmodifiable collection, or you create a copy, for example. So when they mess up with the copy, they mess up with their own copy, right? So this is the philosophy of thread locals. And here we're going to have basically that this thing won't be modifiable, but we could, and we'll get to that, like a subtask can create its own like value for the scoped variable and just scoped value and just go deeper. I guess it will get simpler in code. Yeah. What's important? Thread local doesn't change. I mean, it has its issues, it's difficult, but on the other hand, it's also very flexible. And there are some scenarios where it's basically needed, all its current properties, right? That's why the thread local doesn't change and it doesn't get deprecated. I mean, it's still valid. If you need something mutable that's assigned to a thread, you will still be able to use thread local, but chances are you don't need that thing to be mutable or different per every thread. Therefore, scope value might be a better candidate. And yeah, one of the reasons is if we now go for these virtual threads, and now we create 1 million of virtual threads, right, in just a few seconds, and then if we give this, these threads, every thread, the same thread local, soon we might be doing nothing but garbage collecting, right? So this is one of the reasons. Okay, and this is like a simplified version of the code. It doesn't compile, but it should give us like the idea. I guess it doesn't compile. So let's say we have this clearance level, right? So we need like some permission to get somewhere. And just as with thread local, I guess the idiom would be to create static final thingy, right? And we create, at least in Java 20, new instance of it. And then we can say, and this is why I said it's visible in code. We say scope value and where, right? So this is like, it nests just like try with resources, basically. We can say in this code, we bind to this security clearance level, level from request, right? So there's like HTTP request and we got like some level from this request or something like this. And then we run a lambda. It's like runnable or callable, depending if we have like something to return or not. And then inside this code, whenever I go for this security clearance level or else, for example, or its throw, I mean, its API is quite similar to the optional, right? We get this variable of this type, right? This type. And then, for example, if this level permits to do this operation, we can do some stuff. And if it doesn't permit, we can, for example, signal an error or something. I mean, this is one of the possible scenarios when it could be used like this. And now let's go for an actual example. Oh, lolo, here. Scope values demo. Yes. Any Star Trek fans in the room? Just one person? Okay, Kapla. All right, but you're more or less familiar, right? With, I mean, Jean-Luc Picard, doesn't it ring a bell? Come on, we're in France, I mean, for sake. Okay, let's say we have this starship, and our starship in this very case is Voyager, right? So we're traveling back from the other end of the galaxy. Right, and we're going to have this level from request, and this level from request, it's, as you can see, it's not extracted from request. I just, get a random number, right? So it will get like, and it's also like oversimplistic because it's just an integer, right? But it will do the job, I hope. And we have this, so we have this level from the request, and we have our starship, and this is where we scope this value, right? So to this thing, we assign the level, and then we run this thing. And if I'm not mistaken, it's runnable. See, yeah, it says runnable. Let me try to make this bigger. Yeah, it accepts runnable, and it's also like callable. The other variant, if I'm not mistaken, or maybe yeah, and then I would have to go for call, not run but call. Sorry, yes. Yeah, and then we do some stuff on Voyager. And what's doing this stuff? And in doing this stuff, right, I'm going like this. I don't want to get null pointer exception, right? Therefore, I'm going to say or else -1. Right, something like this. And yeah, I get this security clearance level. And here, as you can see, this is how this story gets so nice, right? Because we're going to use structured task scope, which is using virtual threads. So this is like building on top and on top, right? So we're going to do sorry, English is not my mother tongue as well. 3 things, right? So we're going to turn the lights on. We're going to locate commando Devoxx, and we're going to block bridge controls, right? So everyone is able to control the lights, right? Even if you are a prisoner in a brig, you can tell the computer to turn the lights on or off, right? So your security clearance doesn't matter, right? Because we don't want to torture people with light, with decent people. However, to locate another crew member, you yourself have to have a security clearance level of at least, of at least 2, right? So if you ask computer, where is you need to have security level at least 2, right? And it will tell you that this member is somewhere. I mean, just here, like locate, do random things. And to block the bridge controls, you need to be the captain, right? So I didn't go with like enums, for example, something, just use the numbers, right? And let's see how this thing works, right? Okay. Oh, and there's one more thing, but it's quite fortunate we've run this. Okay, so we've done some stuff, right? And we did it with security clearance level 2, which means we were able to turn the lights on. We weren't able to block the bridge controls, but we were able to tell where Commander Tuvok is, right? He's on deck 9. Okay, and then let's say that for like my subtasks, I can change the security level. So of course I mean, from the business logic point of view, it makes sense only if we make it lower, right? So let's say we put this this request into a prison, right? And then we do some stuff again. And as you can see, then when we're acting with security clearance level, we can only turn the lights on because everything is incorrect. And here is the difference compared to thread local. If we have set it to thread local, and if this was one thread, right, then we would need to make sure that after this, we reinstate this level into thread local, right? And here's the beauty of the scope value. We don't have to do this because this value, level for prisoner, was scoped only to this core, right? Hence the name, scoped value. Right? And after this thing, when we downgraded the privileges, it just basically jumps back to what it was before. And here it's acting again with clearance level 2. As we can see, the commander has moved to another deck. I mean, very fast turbo lift or something, maybe even transporter, don't know. And if we call this thing outside, it wouldn't even have this clearance level. I guess so. Let's do this demo. Do some stuff on Voyager. Right, and let me rerun this demo. Let's see what happens basically. See, and it tells us -1 because -1 is the one I told it in this or else, right? In here, righty. So see, and when I exit or when I leave this, even this outermost scope, which is this thing, it doesn't. I don't have any rubbish in this thread local. Right, I just have it cleared, and then I am relying on the defaults. I could also like throw an exception or whatever I please, just like more or less we're working with the optional, right? And then if we run these millions of virtual threads using this, you see this threads, structured tasks, different names, then it's easier, right? For example, you can set here the level, right? And the methods called inside can check this thingy inside, like here, for example, and based on this, create proper SQL queries, right? Or JPA queries or whatnot, or call the other systems with given privileges, or I don't know, such stuff, right? So that's one possible application for this. Any questions? There's a question. Okay, fellow Star Trek member. I guess so. The question is, what happens if I want to use multiple scope values? I guess I would have to nest the. Let me see. Maybe I just go with another where, I guess. Let me just copy this. Yeah, so I don't have to nest them. I can just chain them, and then run this thing here. So I can compose my environment for this lambda, or just runnable, right? Okay. Uh, I'm sorry, I don't understand the question. Yeah? Mm-hmm. Mm-hmm. I guess you'd like to have like a different level and see what's happening inside, right? So let's see, let's say here, even like this. Let's say 5 and let's say 2. And that's the beauty of deep dives. We have enough time to experiment, right? And now your question is, if I'm not mistaken, is it going to be 2 or is it going to be 5, right? So let's see. And I would say it's 2 because of this, right? So the rightmost, and I guess it's like makes sense, right? To behave like this. Okay. Okay. String, right? And I can go for blah. It works with any object, just like thread local, right? It will work like this. Yeah, it's just an object. I mean, string is already an object. It's not a primitive in Java, right? So I could go, for example, I guess you can go for in stand, right, which is a value object, but I could go for in stand now, right? And this actually this might be also nice. I haven't think about it, but if it wasn't like when we started, so instead of calling instant now everywhere, we can just set one timestamp, right, and then use it in this scope value. As you can see, I mean, I know it's just one value, but I hope it proves the point that we can use any object inside, right? The caveat is if the object is mutable, right, it might not make that much sense. Because if we put it onto a list, for example, array list, and inside I will, for example, add more items to this array list, right? We might still, I mean, I wouldn't do that. But that's risky. That's tricky part, right? But yeah, we can use, as far as I can tell, any object in there. I just used integer because it was simple, right, for the demo purposes. Okay. So yes, they work nicely with structured concurrency. Yeah, there's call here, and yeah, and the words can also be nested, as I have shown you, and then they all overwrite like so. For like it starts to resemble this feudal structure, right? So, for example, a lord can set like lower privileges or something like this for its subjects and so on. Yeah. Okay. We're almost 90 minutes into this talk. And my question is, would you like to have like 10, 15 minutes break, or shall we continue and then let's try to save some time at the end? Who says little break? Who says continue? I'd say it's almost even, but more people would like to have short break. So let's say we meet at 15:10. Would it be okay for you? Like in 12 minutes, okay? Okay, thank you. See you then. All right. Yeah. So we more or less finished the Loom part, the concurrency things, right? So we're going to go into the direction of Amber, Project Amber, and processing data, right? As you may know, record became a standard Java feature in Java 16, right? After 2 preview releases. So if you're using 17, you have records as well, and now it's perceived as a standard data carrier, right? In transparent and for immutable data. Because as far as I can tell, Java beans were kind of like gentleman agreement, you know. So we had the setters if they were mutable, right? And then we had the getters. We had these methods with prefix like get, is, was, has been, perhaps, and whatnot, right? Now we don't have any prefixes for accessors, and that's really nice. That's cool. We have a standard in Java language specification how records should work, behave, and whatnot. Yeah, and the point is the current syntax might not be easy to handle, let's say, data first flows, right? So when your program or system or application is like, you know, sometimes it's more about processing the data than some fancy inter-system communication or whatnot, right? And therefore, creating like a nice code for this code, for this data processing might not be easy. It can look like this, for example, even with the changes that were introduced in Java 16, right? So this aliasing here is part of Java 16. If not that, we would still have to cast this object to be an event, so we'd had even more one more line, right, in Java 15 or Java 11. And this is it. So if this object, this instance of event E, and if this value of this field is bigger than something, then we do something else, we do something. You see, it's like, you understand the code, right? But it's quite verbose, all right? And for the rescue, we have pattern matching for switch to address such situations, to make it nicer, easier to read, and to have nice idioms, right? It's the fourth preview feature in Java 20. As far as I can tell, there haven't been major changes through these 4 previews, except instead of having like 2 @@ or 2 ampersands, they went for when contextual keyword, right? So that's the only change, I mean, at least visible from the surface. Yeah. So when it comes to pattern matching for switch, the nice part is that the good old switch remains the same, whether we're talking about the switch instruction, as we know from Java 7, or switch expression, which we know from Java 14. Nothing has changed, as far as I can tell. If you have seen or detected a change, your code doesn't compile or works in a different way, it means you found a bug, and because it's a preview feature, you're supposed to let the OpenJDK folks know, right? I guess it's not going to be the case, but in case, yeah, please remember this. This example doesn't have the coloring applied because the JavaScript plugin can't keep up with the changes to Java, so it can't like color it properly. But this is more or less how it looks. You see, I have an object, right? It's an object. It's not a primitive. It's not a string. It's not an enum, right? It's an object, and then I can switch on this version of this object, and if it's null, I can do something, right? If it's an integer, when the value of this integer is equal to at least 17, then I'm gonna print hello, this is Java in of this version, right? If it's just an integer, in this case like 16 and below, I will get simply but how, and by default I can just oopsie, right? So this is the essence of these changes that we're going to have in Java soon, because it's still a preview feature, right? So as you can see, no more these ifs now, because if you want to avoid null pointer exception thrown from just by switching, all right, we had to always guard switch with if null, then do something, right? Now it's not needed. I mean, if we don't have this null case, it will still throw null pointer exception, right? It will still behave the same old way. But now we can also accommodate null, and for this, and that's why it's called pattern matching, because we can switch from these versions, and we can also have these so-called guards, right? Yeah. So a couple of facts about this thing. Yeah, a little bit of PowerPoint karaoke. So switch can be now more null friendly and handles objects, so not just the primitives. Dominant cases aren't allowed by compiler. We'll get to that, what the dominant case is. And cases can contain the guards, meaning these when and something, right? Parts of the code. Sealed classes and sealed interfaces don't need defaults. Do you use sealed classes or interfaces? Anyone? Okay, just a few hands. So they were added in Java 17, and what they basically mean, when you create an interface or a class, you can say only this class, that class, and another class or interface can extend me, right? Therefore, we seal it. We explicitly say who's permitted to extend from our class or interface, right? That's why we have this sealing. And we have like one class, and we say only 2 classes can extend this class. Then when you switch from them, it's obvious that compiler doesn't have to expect a third one, right? Because only 2 are permitted, so we don't need the default case. Pattern matching doesn't work with primitives as of now, only with objects. And it works both for switch expression and instruction. The difference is the switch instruction it relies on the side effects, right? Just as like we had in Java like 11, right? For example, and switch expression gives us a value, or as we could say using the keyword, yields us a value, right? So basically what switch returns we could assign to a variable. Yeah, and pattern matching doesn't allow fall through. It also makes sense if you think about it for at least 2 seconds, I guess. Right, so let's go to an example, to a demo, if you will. Pattern matching, where are you, where are you? Oh gosh, pattern matching. I guess this is it. Yeah. Oh yeah, okay, so a quick recap from sealed classes or interfaces. Because they all exist in the same source file, I don't have to go with permit, right? But I could go for permits and then list them: final class, record, and non-sealed class. Meaning, when I have this interface, only this class, and this class can implement this interface, right? And then each of these classes has to be final. And record is implicitly final. Please remember this, record is always final, right? And we can also then go for non-sealed, meaning I'm opting out from this mechanism. That's why I have only 3 options, and it's needed for the other part of this demo. And here we have a quite lengthy file. Let me see if it runs. It should run. Very nice, it runs. What a great demo, it runs. And here, let me try to make this big as well. And let's basically, it's quite simple. Let's just go by these calls to like build understanding what does this code do. Okay, so yeah, switch instruction as of switch 7, as you can see, remains. So this is the good old familiar code. You see, it's still working. It's not gone, right? It will keep working as well. And the switches from Java 14, I mean switch expression, or like this style, this lambda style or arrow style, works as well. Nothing changed here, and nothing also changed. Like, let me try to quickly switch over null. Ignoring this IntelliJ hint, see, and it threw an exception, cannot invoke. Okay, so that's yeah, because hash code, because null, so yeah. See, so they don't change in this regard. Let me run it again. Yeah, but it can handle nulls if we want to, right? So I can go and say, in case it's null, I'm going to print null. And I guess this happened even twice, as you can see, right? And this also works for switch expression, so the one with values. See, if it's null, I can simply return this thing, right? And see, this is the switch expression from Java 14, right? So it returns me a value, right? It sort of acts like a method, if you will. So it works here as well. Very nice. And this is a change that, oh, sorry, there's another change. Yeah, this also changed. I forgot. It's not only one, but it's another thing. Now we can combine this null and default together, right? And yes, so this is it. And where's this other call? Hold on, I can't. Yeah, okay, but the same. Sorry, it's the same method. Silly me. Yeah, and so we can combine null and default. Sorry, does it work as well? Oh, fine. Okay. Sorry. See, like you experiment with things, even with microphone, and you learn something new. Interesting. A very nice backup mechanism, by the way. Okay, so we can switch over classes, as you can see, and I have this object, right? And then I can go, and if it's a string, I can say you're a string, you're an integer, you're a long. I can even match towards arrays, right? Right, and then I can print something, and then if it's something else, I can just say you're something else. So see, you're a string, an integer, a long, you're something else, being an instant, right? And there's a double array, because it also works, why not? And I was switching over these things, right? Yes, and we can now also handle different types without dominant cases, or this, what are these dominant cases? This thing doesn't work, as you can see, right? The compiler says it doesn't work. Why it doesn't work? in plain English? Oh, exactly. That's the correct answer because serializable will always be matched before string because how switch works in Java, it goes from top to bottom, right? And basically it's also like nicer when it comes to like performance, perhaps, because if you have this chain of if-elses, it's going to be linear, right? Because it has to visit every if. Whereas switch can have like a constant or near constant. I have to stop touching this microphone. Near constant complexity, right? And of course, if every string is serializable, then if we match it here, it doesn't make sense to jump here because you can't jump with pattern matching into two cases, right? It's impossible. Fall through doesn't work, right? So this is the case of a dominant case, by the way. And of course, string and integer long are serializable, right? So that's the thing. Yes, so when we were handling this, we should also see like here serializable hello, yeah, like something German here. Okay. Anyway, now switching with patterns. Okay, we can ask who are you, and this is the code that's valid in Java 16, right? So as you can see, we could go for object instance of string, alias it's string, and then check if this string has a length of at least 3, and so the story goes, right? I use that in my Java 16 demos. And now we can do something, yeah, maybe this is better. Something, you guys see it all right? Okay. Expressed like the same logic expressed only in a more concise matter, I would say. So we are matching if it's a string, yes, and when this string has this given length, right, matching this criteria. Then we're gonna jump here. If it's a positive integer, if it's a long that has at least 2 digits, right? And if it's a double array when the first element is 5.0. By the way, this is really dumb, right? Don't compare doubles using equals equals, right? But since we are not recruiting each other, I guess the scope will be just fine. Okay, yeah, and see, this is it, right? So when I pass it high or integer, it says you're something else because we're going to the default, right? I have to pass it, for example, so high is like 2 characters, right? But when I pass it like something else, like hello, right? Then I'm jumping here. And I'm not printing it, but I could go, for example, here and say like string. You see, I can what I matched here, I can also use in this case, right, inside, just like in the previous examples, right? So this is within, and so in this double. See, so your array started with 500, sorry 50, and yeah, this is where things perhaps go a little bit interesting. Yeah, we can't move. If I'm not mistaken, we can't move this thing here. So the default has to be at the very end, right? Else, it's the default still dominates whatever there was up here, right? Yes, let me go back. And with sealed classes, as you have seen in the previous file, right? We know that sealed interface can only have 3 descendants or 3 children, right? So final class, record, or non-sealed class. So therefore, this default is not needed, and even IntelliJ, like, colors it. It's if you color blind, it's like a grayish color, right? Saying this is not needed, basically. Yes, and we cannot use primitives. So see if I'm going to switch over this integer right here, it works because it's switching only of. I mean, this is this good old switch, right? But when I try to switch one of the primitives like this to see if it's an integer or long or boolean, something like this, like I imagined could work here, it doesn't work, right? So it doesn't work with primitives this way. It works with auto boxing, but then of course you will pay the performance penalty because it will have to be auto boxed, right, and extracted and whatnot. And yes, and switch instructions. So not only this lambda style, so to say, but they also work with patterns, as you can see. So I can, if you prefer to have this style with the colon and whatnot, and like returns or breaks, it will still work. However, then you need to remember to put these breaks and returns, right? Because if you don't, normally this code will fall through, right? And here, falling through, if you remember it from the slide, it doesn't make sense, because if I went here, right? Because this thing got matched against FC because it's final classed, and I have this FC aliased. And then when I jump here, I mean, this won't be aliased, so I can't use it here, and I have this FC which can't be used here because it's out of scope, right? So I can't use like FC. So as you can see, it makes sense that fall through doesn't work with pattern matching, right? And therefore, we have to always break it or return it, right? Unless it's the last case. For the last case, it doesn't make any sense. I mean, it's not needed because there's like nothing to fall through, basically. Nowhere to fall through, sorry. And this is it. So as you can see, it's very nice, allows us, like, instead of, maybe it's best seen here, instead of this if-else's, we can have something more concise, right? So this is the whole idea for pattern matching, right? And the story continues in the next step, which is record patterns. Sorry, let's do this again because I forgot. Who's using Scala? No, but just one person. Okay. So, all right. In Scala, there's this concept. I use Scala because I also have like some Scala experience. I guess in Kotlin it also might be applicable to a certain degree. In Scala, we have the concept of case classes, right? And as the name implies, they might be used in the cases, right? And then they allowed us to exclude what's inside. And therefore, I mean, maybe not therefore, I would say luckily, in Java, we'll see something similar, except that case classes are not records and vice versa, but they go in a similar direction, I would say. They try to address the same need only in a different way. Yeah. So, record patterns, right? This is a record, right? And it's quite dummy, but works for the demo. So I'm basically wrapping a double value inside a value, right? So sometimes we do this for our like domain object or something to avoid primitive obsession. And then we can have complex numbers, right? If you didn't have like algebra or something like this at university, like, okay, it's maybe a dad joke, but complex number is a number that you can have a square root of -1, right? This is a complex number, basically. And they have two parts. They are not linear, right? Or like this thing from your perspective, but they can be represented like two axes, right? So we have the horizontal real axis and usually the vertical imaginary axis, and they represent basically a point. If you can think about them like a point, right? And see, so we can have this value and this complex consisting of two values, and then we can switch over them. And as you can see, I can not only I can match it against if it's a value, but I can also match it, like put the whole definition here, right, for the record. So I can match this. It's called record component. Formally, I guess, and then I can match it here as well, so I can go deeper and deeper and deeper, right? It has to be a record, right? And here's like one of the differences versus Scala. In Scala, we could use or write so-called unapply method. In Java, currently, nothing like this is possible, because how does it normally work, right? When we create this object, we call a thing called constructor, right? And sort of to get this thing back to us, let's say we call deconstructor, or we have to deconstruct this object, basically. This is what happens. This object is being deconstructed, or this complex number is being deconstructed. So then we can basically use this R and I variables in here, right? So it's extracted, deconstructed, whatever we call it. I should have a demo for this as well. Let me take a look, because I mean, I can tell different things, but the code will always tell us truth, right? See, and yeah, so this is how we used to work, right? And by the way, this also works with ifs, not just switches, these record patterns, right? So if I'm trying to get something, and this something, as you can see, is a random thing, so I or get like a value or complex or like a rubbish, basically, and then I can try instance of, right? And I can assign this v. So I don't have to go for like instance of value, then I don't have to cast it to value, and then I don't have to call value dot value or anything like this, right? And maybe it's even seen better here. See, if I just stop at the first level, so to say, then I still have to call r.value and i.value. But I can go deeper, right? If this is a record of records, I can basically alias or match this r and match this I, and then basically I can use these, right? And important, or maybe not important, fun fact is, it doesn't have to match the names used in the constructors, right? So when I have this complex and you see it's called real and it's called imaginary, right? And nothing prevents me from using here R and I. Because for example, I find these names here in this context more more useful because short and concise or something. And here is the same example, only written using switch, right? And I can't have these two apparently because it's the same, and this acts to this as a dominant case. Yes, exactly. So I can go like this, right? So it's either I match complex here or I match complex there, right? Something like this. So this is these record patterns. And okay, maybe let's do a little riddle. I mean, I don't know if you had a chance to get your coffee during this short break, but let's try to awake you then. I have these types, quite simple types. I have this record and complex, this we know, right? And I can also have like generic complex, so to say, which can accept anything. It's not just a value, but anything, right? And let's say I can also have this numeric value, just to mimic the example we had here with these two. I can have numeric value, and then this numeric value can be sealed, so it has only like double value or integer value, right? And nothing else. And then I have these generate complex. Let me try to make it like this, which is using this seal type, and the other one which is using this generate complex, which isn't using seal things. This code looks quite similar, right? I would say if you compare it, like it's returning int double double int double double int. So it's every combination it's possible, right, to return in this regard. If we get something extra, I mean, just as a precaution, I'm throwing unsupported operation exception, right? And then when I try to match these, right, when here I have 4 cases, and here I have 4 cases, 5 cases, sorry. And if I try to make 4 cases just like here, somehow it doesn't compile because it says switch does not cover all possible input values. Ideas. I know it's late, but do you have an idea? I'm not sure I have heard you, but let me. Yeah, we need different case because it's not sealed. Is that what you said? Yes, very good. I have the last pack of jellies. Would you like them? Okay, maybe I won't throw, maybe you'll collect them after, okay? By the way, folks, I have like stickers, right? So after the talk, if you fancy, you just come and grab a sticker if you like. Yes, that's the point. It's not sealed. So we have sort of gentleman agreement, right? That we don't produce any other combination, right? But because it's generic complex, it doesn't know that we only stick to ints and doubles. Right, and that's why in here it insists that either I have default or I have this generic number which is covering basically every possible number, right, whatever it is. So this in our flow, this branch will remain dead, so to say. We'll never reach it, but the compiler doesn't know. Yeah, so that's why you see sealed values or relying on records or something might provide you like might be better idea, because then you can simply rely on the compiler and whatnot, right? Okay, yes, that was the thing, and I guess that's all in this example. Oh, I didn't run it. Oh, and nobody yelled at me, it doesn't run. See, so this was this random thingy. This other thing, yeah, I got the complex. So it got like, because we had two ifs, so that's why it's displayed two times from here, this one if and this other if, and this switch produced the last thing, right? Yes. Very nice addition if you're processing data and you're already using records. And by the way, if you're, for example, using JSON, the Jackson library also supports records for like long time. Therefore, like in Spring, you can use records for JSON and whatnot, right? There shouldn't be things preventing you from doing this. Okay, yes, okay, what they allow? They allow the constructing records. Okay, yeah, question? Yeah. 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 Nice question. The question is, if I'm not mistaken, let's say you have more than two fields, like even 20 fields, and do you have to deconstruct using every field, or can you, if I getting this correctly, can I cherry pick, like sort of? Very nice thing. A very nice question. Let's try to do this. So I imagine you'd like to have something like this, for example, right? And as you can see, it doesn't compile. Right, so that's why I like these. For me, these talks are also like a way to familiarize myself with the new Java versions, because then I'm forced to run all of these examples, right, and see if it works. So yeah, one of the differences, at least now, partial matching is not possible, right? We have to go for a value, and then even here it doesn't work because a single underscore or like names starting with underscore got deprecated like several versions ago, right? So we could go for like double underscore. Yeah, but is it really? I don't know. I guess so. Yes. Yeah. I might be mistaken, but I guess so. That's yeah, because nothing like this works as far as I can tell. Yeah, so they allow deconstructing the records, this record patterns with nesting, and for now, no other types. Meaning, if we have Java bean and we know how to deconstruct it, we can't write the opposite constructor or deconstructor or unapplier or extractor, whatever we call it, right? It's this, for now, it's reserved for records only and works with ifs and switches. Okay, and the last part, last big part for today is the native stuff. Okay, so the issue with native stuff is that it can be really unsafe. Okay, so some people, some companies went for. I mean, they desperately needed something to work with off-heap memory, and they were looking for something like this to help them with that in Java, right? In JDK, in all the classes and everything. And then they found this class called Sunmis gonna save, and I mean, what wrong can happen, right? What bad things are ahead of us? I mean, the name says absolutely nothing, right? Why shouldn't we use it? Yeah, I mean, the name tells pretty much everything about it, I guess. So we want to be really safe in three aspects: in time, in range, when it comes to memory, and when it comes to threads. For example, we don't want to have two threads writing to our memory sometimes because reasons. It can be tedious. Who has ever used JNI? Yeah, do you enjoy writing header files? Okay, so we actually, one of the Polish poets wrote quote unquote, and the laughter was his answer, right? So this is what we observed, right? Yeah. yeah, it can be tedious and error prone, and whenever you change like a single thing, you have to rewrite all these files, recompilers, and yeah, so it goes. And it's also like limited. For example, byte buffer, if I'm not mistaken, cannot address more than 2 gigabytes, more or less, because surprise, surprise, they're out of index, right? I mean, the index ends and this is it, right? So we can't get for like 3-4 gigabytes, right? And it also can be slow because of this number of cores, like this way or that way, and therefore we want performance which isn't worse than JNI's and hopefully better, right? So this is the way I see it, the current mindset of the things that happen under the cover of Panama project, and when it comes to interop with the native stuff in Java, right? And I don't know how it's called in French, but there was this American series, Bold and Beautiful. I don't know if you know it, with Bridge and everyone being a lover of everybody else, and it lasted for, I don't know, 7,000-8,000 episodes or something. And I clearly remember this. I mean, for what they were running for, flying for like 200 episodes from Boston to New York or something like this. You know, one of these soap operas, right? And in a way, foreign function and memory API looks similar, because if I'm not mistaken, part of it is under the preview or incubation for like 6th release or something like this, right? But on the other hand, I really appreciate that personally, because I would rather have this thing being baked for longer, and therefore we have like nicer API, safer and whatnot, than having basically another optional .get, right? So I think waiting is better in this regard. And yeah, it's also like, I don't know if it was taught today in the morning, but I didn't take the talk, it was in French, sorry. Yeah, so it also like we'll be able to use this Panama stuff quite nicely when parts of Project Valhalla with value objects kick in, right? So then the performance or the combination of the boost would be even better, like for Vector API. Yes. Okay, let's go quickly over the building blocks of foreign memory access API. So now we're talking about accessing memory, right? And it can be native memory that we access, or we also like manipulate using this API heap memory, right? And it's memory segment. So it's like a region in memory, so like chunk of memory that we're gonna to use, write and read and whatnot. Or it's basically just this, right? Write and read. You can't do anything else. Okay, and then it's memory address. It models an address. And fun fact, sometimes they present you these presentations when they show memory in computer being like 2-dimensional. It's a lie. Memory in computer, it is only like 1-dimensional. It doesn't look like a RAM chipset or something like this, right? So there's only like one number to address the memory. And there's also a thing called memory layout. If like, do you know the concept of structures or structs in C or C++, right? So basically, yeah, even you're nodding, yeah. So basically, it's like this: when you have to access the memory, let's say it's native memory, right? And it was written, because not polluted, it was written by something in C or C++, and you have these structs. Let's say you have an array of structs. There's going to be 5 elements in this array, and every struct looks like this. We're going to have first an integer, then another integer, and let's say we're going to have another structure which has its own signature, right? Something like this, right? And then we can use it and create, if I'm not mistaken, a memory layout saying basically this, right? We're going to have an array of these structures, and each element or each item of this structure looks like this, and so on and so on. Therefore, when you want to go for the 3rd element and for the 2nd field in this substructure, you don't have to calculate the bytes, right? Like with a paper notepad or on your head, or like in algorithm, but you just say you go for the element of index like 2, which is the 3rd element, right? And then you go for field A, and for example for field C or something like this. This is how we want to go. That's why this memory layout is useful, right? And then there's also like arena and memory, segment scope. Previously they were like together, but now they slightly separated, and they provide us boundary for time and thread, and they are really nice for try with resources. And we can also use var handles if you're into var handles to store and fetch elements of this memory, but that's not necessary. I guess, yeah, this is like how it can look like, but maybe let's go into the code. That should be last series of demos for today. I mean, for this talk. Okay, so we have this memory, right? And yes, so first we're going to allocate some native memory in a single thread, and then we're going to write something there. It's going to be rubbish, sorry, and then we're going to read that rubbish, right? So you see what I'm doing here, right? So I basically say memory layout, and I want this to be a sequence of 10 elements, and it's going to be Java ints, so I don't have to worry about, you know, big endian, little endian, and whatnot, right? I basically say it's going to be Java int. And then I open this segment and I say allocate native, so allocate something off heap, so the garbage collector won't mess with my Java int, right? And I open it shared, meaning many threads will be allowed to use it or to access this memory. And then I'm populating this memory, and then I'm examining, trying to see what's in this memory, okay? Let's put it that way. And population is quite simple. I can either use this var handle like this, or I can forget about this var handle, and it's this. See, that's why I'm using this sequence layout in memory segment. So I know this, in this memory segment, I use this layout. It could have been just, yeah, a layout. And then the thing is quite simple. I'm going to loop over this thing. And in this segment, the index of A, I'm going to say or I, I'm going to say set the value of I. Quite simple, right? And I mean, it's oversimplistic, but you can imagine that with this you can go wild and basically choose or set whatever you want. And then we can also like read what's inside this memory. Yeah, I can check the address. I can check if this segment scope is accessible by current thread, which is calling this method, right? And then I can see, for example, again, either I get by an index or I get by var handle what's inside. And let's try to run this demo, and let's hope it works. Yeah, it worked. See, and it's just as we expected, or I expected. We're checking this memory. It can be accessed by this thread, and by at index 0, we keep value 0, and so on and so on. But we did it off heap. So now, as you can see, to manipulate memory off heap, you don't have to know C or write header files or anything like this, right? Yeah, you can just do that, right? So it's you're not doomed or always doomed with garbage collector if you see garbage collector as a doomy thingy. And now 2 threads, right? Let's try to do with 2 threads. And again, I'm going. And yeah, sorry, one more important thing, because I said it gives us the boundaries, right? See, 10 appeared only here. I'm saying here I want to have the sequence layout of 10 elements. And here, when I have this loop, or here I have this loop, I don't have to keep this if it's 10 elements or not, right? See, basically I can rely on this layout. So if I do a mistake here and say I want to set something which is like doesn't belong to the memory or is beyond the memory I allocated, right? Then see, it told me index out of bounds. That's why it's providing this safety in a space, in a scope, right? It doesn't allow me to go and, like, you know, the famous strcpy bug in C++ years ago, right? Yes. So now I'm trying to do this with 2 threads, right? And 2 threads looks like this. Yeah, now I'm opening an arena which is confined, meaning only this thread will be able to access this scope of memory, right? This memory segment or whatever. And again, I'm allocating the same in this arena's scope, and I'm populating this memory and reading from this memory. And let's see what happens. Oh, it doesn't work. And very nice, because now it shouldn't work. See, I closed this arena before I left this try with resources, right? That's why I said it's very nice because it provides us also like automatic boundaries. I closed this, therefore this examination couldn't succeed because this arena or this memory, basically this chunk of memory was already freed, right? That's why it said it's already closed. What are you trying to do? Silly developer. Very nice, right? That's so when I don't close it prematurely and just rely on that it's auto closable by try with resources. See, it works. It's as it works as it's supposed to work. However, what happens if I open a thread, right? And it's another thread. It's not the thread that created this memory, but another thread. And in that thread, I want to check what's inside the memory. Then I can go and see, and it tells me attempted access outside owning thread, right? So see, now it's not that with these measures you cannot do stupid things. We still can, right? Because we're clever when it comes to doing stupid things. I mean, myself included. But as you can see, it makes it really more difficult. And now, with just Java API, we can call native stuff, native memory, right? And write there and read from there. And you might be thinking, I mean, what's the big buzz? I mean, if there are people like we're working with or on like super fast caches, right? And they don't want to and then garbage collector would slow them and whatnot, and then they use this this native memory. But for us, it's not that much needed, right? Maybe it is. And let me introduce you foreign linker API, the other part of this JEP. After I answer a question, there's a question. I'm sorry, could you repeat, please? Yeah. Oh, that's a question is, could we use memory as an alternative instead of scope value? I guess in theory, yes, but I like. What would be the advantage? I mean, the scope value is read-only by default, right? So I guess it's not going to be garbage collected as long as we're in this scope, right? So I guess we could use the native memory as a kind of like communication passing mechanism, but I'm not so sure I would do that because this thing is more complicated, convoluted, I would say, risky as well. Right, to a certain degree. So yeah, and technically it's possible, yeah. But any other questions? Yeah, this.
Could you write the children threads to access the memory?
Yeah, but so you'd like to create but then, like, what do you understand as children thread? Because this arena was created by this thread and this, right, the thread running this method, right? And this thread was created by this thread as well, right? So if, because the question is, could I create a child thread and to tell this thread that it could go there, right? You touched a very nice part of it. As I said, this is like a 6th version of Java when we see this or something. And this thing is the most changing part, really. Like in previous previews. Yes, it makes sense. Actually, it's valid English. In previews. Yes, it looked different. I could check which thread owns this memory, right? Now, as far as I can tell, I couldn't find this in API. I cannot check which thread has access to it, but I can check if it's accessible by me, right? Or like any other thread, if I could pass it here, because it doesn't have to be current thread. It can be, sorry, any other thread as well. I like the area or the direction in which your thoughts are going. Like, try to marry this in a way with the scope values and like subtask and so on. I'm really puzzled what kind of systems you folks develop. I mean, it's really, I would love to hear that, because Such questions usually aren't asked by people who just create regular e-commerce and like parse JSONs or XML files. Like, I'm not trying to offend anyone, of course. It's just it gives or requires certain. Let me put it that way. It requires certain real problems to ask such questions, right? Yes. So there is this sibling or the other child of this JEP. Previously, they used to be separate JEPs or something. Now they are merged together, and it's foreign linker API, which coexists in this JEP now with foreign memory access. And this is it. Like, let's think about it for a second, right? If you have a function in C++, right? I guess it's not that common that you want to just call this function for some side effects. Usually, you want to pass this function some data, so it does something, or you want to get the data that it produced, or even both, right? So how do we communicate with a function written in C? By a memory, right? And this is why this previous step is prerequisite for this foreign linker API. Right? Because to call a function from C, we need to prepare some memory for it, or we need to read the memory that it prepared for us. All right? And yeah, so the whole idea behind foreign link API is to replace JNI with, again, pure Java thingy, so no .h files, not .o files, and other like nasty stuff like this. I mean, it's not nasty, but it's like not easy for us Java folks. And right now it supports only C for these architectures. However, it's promising. I mean, one day it could be extended for C++ or 32 bits. Again, performance should be worse than the one of JNIs. And what does linker allow? It allows us two things, so-called down calls and up calls. And down calls are quite simple. So you just have this function in C, and you just call it, and that's it. And if it like created something, it returns something. You just read what it returned, right? That's it. But there's like I haven't come with a better example for up call, but it's for example we have very nice sorting algorithm written in C, and we don't want to port it into Java because budget, because I don't know, it's so well tested in C++ or whatnot. But we have the comparator for the elements that have to be sorted written in Java, right? So we do the following thing. We create the comparator, and we pass sort of the reference or a pointer of the comparator to the thing that we're going to call from C, and the C, when it's going to be sorting the elements, it's going to call our Java back. It's going to not only be called C down, but C is now going to call us up. That's why it's called up call, right? I won't demo this, no worries. Yeah, but this is what it allows us. And you might be thinking in general, why bother so much with linker in general? Because it's simple stuff. You prepare a message, it's sort of like a memory. You call C stuff, and then you read what it left. I mean, what a big deal. The thing is, how do you create or allocate memory in C? How's it called? Malloc, exactly. And how do you free the memory? Free, exactly. And how do you allocate memory in Java? Yeah, with new. And how do you free it? Garbage collector does it. And what can garbage collector do as well? It can shuffle the memory, right? It can compact the memory, defragment it, if you will, right? And now this is a concept virtually unknown in C. Because in C, when you malloc memory, it's allocated until you free it. There's no like moving it around during the lifetime of the process, right? And this is like, I mean, one of the cornerstones of Java these days. That when you have a compacting garbage collector, it moves things, right? Be like old gen, new gen, stuff like this, Java memory model and whatnot. And if you think about it, that how like this memory exists and whatnot, and how do you pass data so then when it's like compacted, for example, by garbage collector, the C still knows how to access and so on. That's why we need this whole layer in between, and that's why it takes so many years to do it properly, I would say. And that's why it's huge effort, and it's trivial to call or to use it. I hope it. I'll show you that right now. But yeah, I really, I mean, I guess I know why it takes so much time, and I really appreciate all the big brains working on this. Really, it's not trivial stuff. Okay, the last demo for today, I guess, and I don't know if you have ever seen one of the Brian Vermeer's. I'm mispronouncing his last name. I mean the Snick guy. Have you seen like the security talks of Brian? Very nice security talks. If I'm not mistaken, in one of his talks he says, it's not wise to run your stuff as a root. Do you agree? Your programs as a root. Okay, yeah, you seem to agree. Okay. Okay, very nice. Yeah, we shouldn't run our stuff as root. And then how can we check it? For example, we can like create our Java program in a way that it can check if it's run as root and, for example, refuse to run as root, right? Let's have this simple story as our last demo, right? And this is what we do. So I have this foreign linker API demo, and it checks the UID, and it's going to report us to tell us what UID it's using. And if it's run as root, then it's going to say, no, 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 please don't run me as root, right? I don't want to be run as root. It's too dangerous. And then how we check if it's UID, it's this example, right? This is the whole native or just the linker thingy. So according to this manual page, please be friends with this funny and very friendly Spanish guy called Manuel, right? So we get the native linker, and then we create like standard or handle for standard library. I'm using vars here because it's like more concise, right? And then again, we follow this optional pattern, right? We try to find this the handle for the getUID function, right? And if it's not there, we should throw an exception, because let's be verbose about our misfortune, right? And then let's say it's going to return us just Java short. See, so this is the description, sort of methods. I like to think about it as a method signature, right? So method signature has, for example, the return type and the type of the arguments, right? So this is more or less this. It's not exactly this, but more or less this, right? And then I'm going to create this down call handle. See, so I'm going just to call the C stuff, right? So this is the handle of the function, and this is how the function should be shaped, right, or handled. And I'm basically going to invoke it, and here I'm going to return this. So see, we have this foreign memory API even working under the hood, sort of, right? And yeah, and then I'm just checking if it's UID equals 0. And then people were like, okay, very nice demo, but you're cheating because you're running this on Linux, right? And it always works on your machine because it's Linux, standard library, and so on. And I'm like, I'm a Windows or Mac OS guy. I don't have to worry about these things, right? Question is it really how your stuff works in production? Maybe it still runs on like Kubernetes, Linux, and whatnot, right? And then I decided, after showing this demo several times, let's, remember Control-Shift-T, right? And it will create you a test or take you to a test, right? So before you check in or commit or push your code, you always Control-Shift-T. And again, surprise, surprise, what can Atomic Jar do? Show you a test using test containers, right? So it's going to be a simpler version of what we saw before. See, I've created this. This is what we do normally using Maven, right, or Gradle. So we're creating this jar, and what I'm doing here again, I'm going to create a OpenJDK container, right? Copy my file there, and then basically I'm going to call it, right? And then I have this execution result, and I'm checking if this exit code is different than 0. Because when it's root, I just want it to exit with non-standard code, right? I don't care if it's 42, 17, or God knows what I did. I just want it to be non-zero, right? So non-successful, and then I'm checking standard error if it contains "oh no, I don't run me as root." So this is how I want to check this functionality, and it will work on your machine, even if it's Windows or Mac OS and so on, just as long as you can run test containers, right? I hope. So let's, I hope it will work. Let's see if it works right now. Come on. Yes, I'm using the test containers cloud again. That's why, despite the conference network might not be the fastest, it should be okay, because I just needed to communicate with the container out there. Yes, and it works, which means that the program exited with non-zero code, right? And in the output, it was written, "oh no, don't run me as code," right? And this is really as easy as it takes, you see, to create your infrastructure for testing, no matter what operating system you use. So now you have no excuse. You can create or run the demos as well. And by the way, if you clicked, somehow I failed and I didn't publish the slides under the link, so the link has been fixed. It's working right now, right? And the code should be also there and whatnot. Some various other changes, and we're going back to the beginning. There have been changes. There are almost changes to garbage collectors in Java versions. So see, even if you have your jar from external vendor, but it works on the Java version you have, right? On the newest Java version, you should upgrade it, because, for example, your garbage collector will be performing better because there are changes to garbage collectors. So we don't have to change your code to benefit from better performance, basically, because JDK under the hood is better, right, with every release. Yes, there's automatic generation of the CDS archives. As I said, if you can't graph VAM your system and you'd like to shorten the startup times, you should really you should Google or DuckDuckGo CDS archive, right? And the newer version you have of Java, the easier it is to use, because when it was introduced, we had to generate these archives manually. Now it's more and more automatic. Java 17 and 20, sorry, 19 and 20 now support Unicode 14 and 15, because apparently we need all these new emojis and other stuff. I don't know, it might be a crucial importance, to have 20 new emojis. Okay, now we also have 2 new system properties, standard output encoding and standard error encoding. Turns out for 26 or 7 years, we were writing to standard output like savages without knowing what encoding actually to use, right? Yeah, now we can know. There are additional datetime formats, and this is really a funny thing. Okay, that's gonna be quick demo. Oh, not this thing. Oh, okay, I have it as another project. Basically, in Java 19, there are also new datetime formats which can produce you nice abbreviation of the month, right? So, for example, in French, it will end with a dot. In other languages, it won't end with a dot, if I remember it correctly. Yeah, and there are also new methods to create pre-allocated hash maps and hash sets. Say you are creating a map, and you know that in this map, because you use it for your constants or whatever, you're going to need 100 elements, right? So instead of creating new empty hash map and adding elements, and then when it discovers that there's no more room, right? Or in set, then it creates a bigger one, copies the elements and whatnot, right? If you know from the beginning how big a map or set you need, you can tell it explicitly, hey, create me a map or set for, let's say, 100 or 1,000 elements or whatnot, right? So it will be excessively big at the beginning, but you'll use all the space, right? Some stuff got deprecated, my friends, like locally constructors. Now you're not supposed to call new locally, but use locally.off to get the locality, and it's getting us closer to value objects, Project Valhalla. So maybe we'll, or one day, Vikings, reach Valhalla. And so the same for URL constructors. Now we are supposed to create URIs, and from URIs call a method to URL or something like this. Some stuff got removed. sort of removed. Now, as of Java 20, methods in thread, even in platform thread, right? Good old thread, like suspend, resume, and stop would also throw unsupported operation exception, just like the virtual threads, if I'm not mistaken. And the support for Java 7 has been dropped in Java 20, meaning you are no longer able to, using Java 20, create binaries for Java 7, right? For example. And this is when I'm getting really excited about these things. So we're going to have these things most probably in Java 21 this autumn. So string templates, right? So we won't have to concatenate or string build things. Sequence collections, record patterns, and pattern matching for switch, right? So let's see. The links should be clickable. See, it's candidate. If it's candidate and not a preview, it means it should be like a standard feature, right? So we won't have to use this enable preview or add modules or anything like this, right? And this is where things get really exciting. I might have forgotten to add the link to the JEP. No, okay, it's written here. It's JEP 425. It was the original, right? And this is like a new JEP. And what it says here is that this JEP proposes to finalize virtual threads in JDK 21, which means, and it will be very nice, connect, like, how is it called? A conjunction of planets, right? Or whatever, that we're going to get like new LTS in autumn, in September. And it's going to have not only these stringy thingies, which are very nice and so on, right, or pattern matching, but also virtual threads as a standard feature. And I don't want to get too American, but it's awesome, right? And there's like one other thing that makes me really excited. As a former bootcamp teacher, is this enhanced main methods and anonymous main classes. It doesn't tell you a lot or maybe it does. You know this, right? You know this all too well. And then try to teach somebody Java starting with the, okay, so this is the logic that you need, this single line, everything else is just ceremony, right? So we should be able to simplify it like this. See, so the class, I forgot, like static, it's the method. I forgot to put it like a public static void in here, sorry. Yeah, I forgot it. But see, it doesn't have to be public or like something like this. It's just the main thing. And maybe if it even will work with this, with this calling sources just using Java like this. So we won't even need a class, right? So it would be really nice to write scripts, like interpreted scripts for like one-time migrations, simple, short stuff, or teaching people Java, right? So if you just go like with a notepad, I mean notepad.exe on Windows, right? We won't have to go with this. Let's just paste it. It's ceremony. The ceremony is going to be gone. See, like also not this thing. It's beautiful. Yes, very nice. We'll still have some time for like coffee and whatnot. And now I'd like to ask you something in return. And the thing is to always and for everyone, like every event, provide feedback. And since this is not a virtual thing, you can even pass me a paper form. And I know you have like this Devoxx app, so this Devoxx app should be like the primary way you rate your talks and so on. And just please, not just this talk, no mind talk, okay? You're going to attend more talks today, tomorrow, and on Friday as well. And it's really important for the speakers and the organizers. So on their behalf, I ask you to submit your feedback, right? And if you don't want to use the app because reasons, or you can't use the app because you're just watching this on YouTube, this link should be working. This is an anonymous poll, right? So it's not the Devoxx apps. It's just my simple Google form with, I don't know, 4 questions, anonymous questions. So if you'd like to avoid Devoxx feedback form and you have to have like a backup or fallback, this is the fallback, right? I guess this is it. folks, this is a link for the code that I was showing you today, GitHub repository, right? And yeah, merci beaucoup. And should you like to follow like this funny Polish dude with the unspeakable name for like more IT insights, Java tips, or just pool life advices, please follow me on Twitter or Mastodon. Yes, and this is the link. It's working now for all the slides and code and everything. If you'd like to deepen your knowledge or get just familiar with test containers, I'll be having this workshop tomorrow at 10:45, if I'm not mistaken. And for everybody else, for everything else, I'll be hanging around so you can like catch me and we can have like lovely chat about Java or meaning of anything. Thank you very much.